So I want to try this video thing out, and this is the first one, so we'll see how it goes. Okay. When you're proving trig identities, you have to start with one side of the equation and use equivalent quantities, meaning things that are equal to each other, that are logical to use, and try to work your way to the other side of the equation. Some people might get there quicker than others. Others might take a long time, just depending on what quantities you set equal to each other. But nothing's wrong as long as it's equivalent to each other. So let's try to do this double angle identity. I want to prove cosine 2x is equal to 1 minus 2 sine squared x. So the first thing I want to do is start with my left side, cosine 2x, and work my way to the other side, 1 minus 2 sine squared x. So I'm going to start with cosine 2x. So I know cosine 2x is the same thing as saying cosine x plus x. And if you have something like that, cosine 2x, you can always break it up into x plus x. Or if you have something like cosine 3x, you could say 2x plus x. But we'll get to that probably tomorrow. So if I have that, I know this is a sum identity. And that sum identity for cosine x plus s would be cosine a plus b, which is cosine a cosine b minus sine a sine b. But in my case, I have cosine x plus x, so instead of the a's and the b's, it's just going to be x's. So if I plug that in using that identity, I'd have cosine x minus sine x sine x. We're running into each other. So cosine x times cosine x plus sine x times sine x would be the same thing as cosine x squared, because I'm multiplying it by itself, minus sine x squared. And the shorthand for that is cosine squared x minus sine squared x. So I'm getting closer to what I want. I want 1 minus 2 sine squared x. That's up here. So in that identity, I don't have a cosine, but down here I do. So I need to get rid of this cosine squared x somehow. I know from the Pythagorean identity sine squared x plus cosine squared x equals 1. So if I want cosine squared x by itself, I could say cosine squared x would equal 1 minus sine squared x. I would just move the sine squared x over to the other side by subtracting it. So if I know cosine squared x is equal to 1 minus sine squared x, I can plug this quantity into my cosine squared x in this proof over here. So instead of cosine squared x, I'm going to write 1 minus sine squared x. Now if I have minus sine squared x minus sine squared x, I have two of those quantities. So I have 1 minus 2 sine squared x, which is what I wanted to prove. I wanted to start with cosine 2x and work my way to prove that it is the same thing as 1 minus 2 sine squared x, which I did. Now I would like you to try to prove cosine 2x is equal to 2 cosine squared x minus 1, another double angle identity. So try that on your own and bring it to class tomorrow.